Hello and welcome to section 3.2, which is on properties of parallel lines. So postulate 3.1 covers the same side interior angles postulate, and that really just says that if there's a transversal that intersects two parallel lines, then the same side interior angles are supplementary. And I'm going to show you examples of this here in a second. I'll just do them all at once. Theorem 3.1, alternate interior angles theorem. If a transversal intersects two parallel lines, then alternate interior angles are congruent. Again, why do we need to know these? Because you're going to have to know the rules or the theorems that go along with the proofs that we're going to be doing. Theorem 3.2, corresponding angles theorem. If a transversal intersects two parallel lines, then corresponding angles are congruent. Now, if you remember from section 1 that we did previously, we talked about all these things: alternate interior, alternate exterior, corresponding, what they all were. And I have a picture here in just a little bit that I'll show you and we'll go over it. Theorem 3.3, alternate exterior angles theorem. If a transversal intersects two parallel lines, then alternate exterior angles are congruent. Again, key thing is here, like in this picture, these two lines, there has to be a set of parallel lines. So this one and this one would be parallel, and here is my transversal which cuts it. And so then if we just work our way backwards up the list we just went through, I'll show you an example. Alternate exterior. So 1 and 8 would be alternate exterior. 2 and 7 would be alternate exterior. They are on the outside and they are opposite of each other. Okay, and so those are congruent. You know that because it's cutting a set of parallel lines. It's making equal angles when it does that. Corresponding angles would be 1 and 5, 3 and 7, 8 and 4, 6 and 2. They hold the same position on the same side of the transversal. So 2 and 6 would be congruent. Moving back up the list, the alternate interior angles. So alternate interior would be 3 and 6. They're on the inside of the parallel lines and they are opposite each other. Those are congruent. And then 4 and 5 would be congruent as well because they are alternate interior. And the first one we went over was the same side interior angles postulate. Same side interior angles are supplementary. So what's that saying is 4 and 6 interior, and they're on the same side. 4 and 6 would be supplementary. So would 5 and 3. So to go to an actual problem, if I want to find the value of x here with this trapezoid, the reason I can use those same rules I just went through is because the trapezoid has a set of parallel lines right here, here and here, that's parallel to each other. So let me grab, actually let's do it like this. So in here, if I use my same side interior angles, right, if I continued this line out, and this is my transversal, these would be same side interior angles, so they would add up to 180. So then to solve this, I could go x plus x minus 50 equals 180. How do I know that? Because that theorem that we just went through said that they were supplementary, which means 180. So then I could combine, actually let's get rid of this, so I'm going to go plus 50 on both sides of the equal sign, so plus 50. That gets rid of this. I'm just going to go ahead and write it so that x plus x would be 2x equals the 180 plus the 50 would be 230. And then how do I get rid of the 2? I'm going to divide by 2. So then my x equals 115. But that is not my answer. Oh yeah, find the value of x. So the other one would be x is 115, and then this x minus 50 would be 115 minus 50, which would be 65. And so you could check it by saying, is 115 plus 65 180? And yes, it is. So it does work. So there I'm using all those rules to be able to do that. So on this one, if I want to find the measure of angles 1 and 2, and I want to be able to justify my answer, meaning I have to give reasons why things are the way that they are, using the theorems and postulates that we just went over, measure of angle 1 equals 120 degrees. How do I know that? Because corresponding angles are congruent. So corresponding angles, if I gave you this one and I said it's 120 and these two lines are parallel, I know that the corresponding angle to this one, which would be angle 1, is 120. So then measure of angle 2 would equal 60. How do I know that? Because of the same side interior angles. And I'll just put equals 180. Same side interior. This one and this one. Same side interior. These two have to add up to 180. Plus the fact that these two make a straight line and they have to add up to 180 as well. So if this is 120, this has to be 60. So then the last thing here is we're going to do a proof using this information right here. And we want to prove the corresponding angles theorem, why it works, that theorem 3.2 that we just went over. So if they give us the information that K is parallel to M right here, K and M are parallel, and this is my transversal, and then I plugged some of this stuff in here, I want to prove that angles 2 and angle 6, which are corresponding angles, are congruent. Okay, so I need to work my way through there to try to figure this out. So then I'm going to come down here. Whoops. Didn't want to do that. Hang on. Okay, so the first thing I know is that K is parallel. K is parallel to M. I know that. How do I know it? It's given. They told me about it. So then I know that measure of angle 2 and measure of angle 3 equal 180. How do I know that? Because they are a linear pair. Measure of angle 3 and measure of angle 6 equal 180. How do I know this? That same side rule that we just went over. Same side interior angles are congruent. Okay, so from there, what's my next logical step? So now I've said that 2 and 3 are 180, and I also said that 3 and 6 are 180. So I have that much figured out. So measure of angle 2 and measure of angle 3 equals measure of angle 3 and put a plus there and measure of angle 6. How do I know that? I just proved it right here, right? So substitution. That's how I did that. So then measure of angle 2 equals measure of angle 6. How do I know that? Subtraction property of equality. I subtracted 3 from this side and 3 from this side, and I'm left with 2 and 6. So what's left to say here? That the measure of angle 2 is congruent. Sorry about that, I had to find the congruent mark there. Is congruent to the measure of angle 6. And how do I know that? It's the definition of congruence. What does congruence mean? It means that they're equal. So there I've used some more of my new rules to be able to work our way through a proof. Bring that knowledge with you. We'll talk about it more next time I see you. Have a good night.